and it reduces your chances of getting the good data sets. In fact, the first data set that you have, practice set, it's really important because based on that you get the next data sets. If you didn't do it correctly, you won't get the next subsequent data sets. So it's very important to do the practice set quite accurately. So I'll be demonstrating on two data sets, a data set from my campaign on which I discovered an asteroid, and also on the practice data set for Saicharan's team, so that it's easy. Yes, Saurabh, please go ahead.
Yeah, we haven't been provided with a registration key yet.
Sorry.
We haven't been provided with a registration key yet. How do
Uh,
we register?
no. So it's same for all of IASC. It's not specific to you. Let me see. It was somewhere mentioned in this document only. The license and key is provided by email only to citizen science groups participating in an asteroid search campaign. However, you can use Astrometrica on a limited basis for 100 days without the license and key. Saichiran, could you go over that?
I'm not exactly sure, sir, what you mean by a session key. Can you please elaborate on that?
All right.
Here
So
on that page, could you please lower a bit? Here it says to register, right? And after registering only, we will be able to do the analysis for asteroids. Then how do we register? We don't have a key yet.
Yeah, I think you're talking about Astrometrica registration.
Yeah,
Yeah, in the email, the key has been provided, the one you sent by IASC, but it's fine. But for 100 days, you can still use it without a key. So it shouldn't be a problem either ways.
the reason I suggest using this key is because if you head over to file, okay, by the way, have you guys downloaded Astrometrica by chance?
yeah, I have.
All right, awesome. So if you head over to settings in the under file, you'll see observing site, and under that you'll see observer j.pulgar t.loe, and these names. So these names will be automatically loaded if you use this registration key. If not, you'll have to type those names in yourself, and you'll have to exactly provide which asteroid you're using, the MPC code, and all these things. But I will go through all of this as well, so that it's comfortable. Does that solve your query, Saurabh?
Yeah, for now, yes. Thank you.
All right, awesome.
I just found the software key on their emails. I just pasted it in the chat box so that you can
Yeah,
quickly.
please.
Okay, it's not there in this document either. All right, let's start. Let me start by joining in from the Windows. I'll be just a minute, guys. Thanks. All right. Saichiran, could you make me the host on the other ID as well, the co-host?
Yeah, sure.
Yeah. All right. Um, all right. So I've already logged in from here. You'll head over to campaigns, then CD they've gone. Better class. Is my video lagging? The screen, is it lagging?
I think it is. I think it is.
Yeah, because on my laptop, I can see something that was there a minute ago. Okay, let me close this one. It'll be probably better. Yeah, yeah, now it's fine. All right. So I have already opened Astrometrica here. Each time you open Astrometrica, there'll be a command prompt that'll open, and that command prompt will load the MPC orbital database each time to see if there's any updated thing. Don't rush off on that. That's important. So let's start by importing the files. Are you all following along, or is it just me showing how to do it? Hello? Am I audible?
Oh, yes. Yes, you're. Yeah, you're audible.
Okay, so go over to 5 and load images. Then you'll have to select all the 4 images at once, and it'll stack these 4 images on top of each other like this. Not literally stack it. After this, the first thing that you want to do is reduce the data. So astrometric data reduction is basically when the telescope records the data on a CCD, it also records a lot of aberrations because of the atmosphere or because of general noise in space. I mean, not real noise, but data wise noise. And so this would basically just reduce all of that noise and clean up the data so that it's easy for us to use it. And it'll also see what stars are there so that we can have kind of like a geography of where we are, so that the next step that we perform, that is the known object overlay, basically seeing the previous asteroid discoveries in this region, it'll be easier for us to reference which is there. So by the way, this is a FITS file. So it's something like, I forgot the full form. It's like flexible image transport system. Yeah. So FITS is used to transport scientific data. It's also used in volcanology, apart from astronomy. So yeah, this will show reference star match error. This happens on some machines, it doesn't on others. So if it does happen for you, continue with automatic reference star match using 200 stars. So after that, yeah, I was saying, so FITS is used to transport volcanology data as well, apart from astronomy. But it is easy for us to transport all of data because you need to have data like what kind of telescope you used or stuff. So firstly, before that, you'll have to head over to file and settings, and under observing side, make sure that your MPC code is F51. You guys can click screenshots of this because they should be exactly as it is. These are the specifications of the um, telescope itself. Then you really don't need to fill this data. It's done when you are uploading the MPC report file directly from Astrometrica. But since we are not doing that because we technically don't own this data, we won't be doing that. We'll have to upload it through IASC, and then IASC will send it over to MPC. So the observers, these are the names. If they aren't loaded like this, then just make sure to click a screenshot of this and put it up physically, manually, when you are logging on to Astrometrica. Here under measurer, it should be your name with the first letter of your name and then just your surname. And in bracket, it should be your team name. So for and your country. So here, sorry, the team name and the country. So in this case, the last I participated was in a Spaceport India thing. So it has Spaceport India, comma India in bracket, and make sure that the telescope is this 1.8. Then rest of the things are pretty standard. So we don't have any kind of problem there. Yes, you can also do this one additional thing that's easier for kind of arranging the data when you're working with it. is that you can create a separate folder under C, Astrometrica, and data, where you can add each separate file, give it some name, and then once you create an Excel sheet referencing that file name and the asteroid name, the name of that asteroid, if you detected, that you assign to it. Now, the benefit of it is that it's kind of like you get bragging rights in the future. So if you have recorded this, you'll know which file did your discovery come from and which asteroid particularly was that. So that let's say if you discover an asteroid that is in fact a provisional result, you'll be able to show people that this is exactly the asteroid that you detected. So it'll be kind of cool. But that's just optional. You can maintain something like this. I did. That's why this is the file from which I discovered. Yeah. So
Okay.
sorry. Yeah, go
Sorry
ahead.
for interrupting. Can you just explain the part of measurer in program setting? What should be the format?
Sorry, could you go again?
What should be the format in measurer under program settings?
All right. So the measure should be your first name, only the first letter of your first name with a dot, and then a space and your surname. And then in the bracket, the name of your team. That is, for instance, for me, it was Spaceport India, and then comma, it'll be India. So the country from where we are participating, right? It doesn't have to be your physical geolocation at all. It just has to be the country that is mentioned beside your team name on the Astrometrica folder. So I'll show it to you guys. Just give me a second. Yeah. So if you head over to campaigns, then CB Devkan. So this is the country you should put in. In fact, it's India for all of us. So don't go on your physical location. Just put in the IAAA-Petal quiz, and that should be it, right? Does that clear it out? I don't know who asked it.
Yeah, Joy. Thank you.
And if you're participating in a team, you'll have to have others' name as well with a comma, and then in bracket for common for all of them, just put in the team name and India. But if you're in it participating in a team, mention that everyone's name is there, so that it can correlate with the data that you put in on the website, right?
Should it be like all the four names followed by comma and in bracket the team name?
No, the say J. Agrawal, comma, S. Charan, and then in
Okay.
bracket IAAA India, something
Okay,
like
so
that.
all the four members with the team name.
Yeah, but comma separated. That's
Okay.
important.
Okay.
All right. So now that we're done with housekeeping, let's move on to the actual stuff. Yeah, now we want to do known object overlay. So that'll just reference the stars, the rough position, and then compare with the MPC orbital database to detect any known asteroids in this area, and it'll just mark it so that you don't upload those asteroids. Please make sure that you don't upload the data of a known asteroid. Otherwise, as I said, it'll just take up their computing power, right? So now everything is done that had to be done beforehand. Now all you have to do is blink the current images. So it'll create sort of an animation of all the four images with some, let's say here it's 3, so it blinks 3 times. Then just zoom in to the, sorry, second. Yeah, now it's zoomed in. So zoom in twice. That's what I standard as I follow as a standard. So it's easier for me to work with. All right. So just narrow it down to one square tile and then start looking manually for objects that you can see moving. Make sure that you will not definitely see any object moving in the first time at the first time. You'll have to concentrate more and start with kind of like a search pattern. So you'll have to start from the top corner and then move like this. It's basically on your visual power that how well can you see the asteroid. It can be very small, it can be in all shapes or sizes. But yeah, but make sure it's not going to be extremely long and then you'll say, oh, it's a comet or it's a spaceship. No, that's not possible. It'll be mostly round. It can be let's say a bit oval, but it won't have any sharp edges. So make sure to keep track of that. And then if you don't see anything here, just slide towards the right, towards the next tile. So yeah, this is a fun exercise. Can anyone see any moving objects here? You can unmute yourself.
Yeah, there is one in middle and the little towards the left.
Yeah, awesome. So these are the two images, these are the two asteroids that are moving. So I think there's some kind of an error here with Astrometrica, the software, because this thing should be here instead of there. It should be on one of them. So we probably did there was an error committed in the data reduction. But anyway, so you'll let's say we want to uh, say that this asteroid is a new discovery by us. Then you will stop this. You'll make sure that it is actually when you single step forward and go back to the first image. So you'll be able to automatically see a pattern image emerging. So it'll be definitely a straight line. It would be at least this much long. It won't be very short. So let's find something that is very short or different in this so that I can show you which is not an asteroid. Just a second. Let's find something that's not an asteroid but seems like it's an asteroid. Yeah, so if you see here, this something feels like there's something moving in this direction. So yeah, if you see something here, there's a little bit of a black something there. And then if you go back, you'll see something here. So this is not an asteroid. It'll travel a little bit longer and it'll be a little bit larger in size. And you have to make sure that you see a continuous streak rather than just 2 points, which are separated by two images. That's not really possible. So in this case, if you click on it, you'll see that the signal to noise ratio, where is it? SNR is very low. So SNR should technically be a little bit more than 3.9. It should be somewhere around 10. That's the standard value that IASC would accept. But if you see something that's clear enough to your eyes, but its SNR is not really 10, I don't see any harm in just putting it up on the software, because after the practice set, they can't really disqualify you or remove you or something. So it's fine. If you see something moving, its SNR is not really very close to 10. Uh, let's say it's 7 or it's 8, then fine, it's still fine, right? Yeah, let's move to the actual asteroid that we saw. Yeah, this thing. So we'll click here or exactly on the asteroid. Don't click on the stars or anything and upload that to MPC. It won't be of any use, obviously. Yeah. Once you're here, you'll see that the SNR for this is 5.2, but as I said, we can see it moving clearly and we can feel that it's an asteroid. Then it's fine. We can put it up. We exactly don't know how the algorithm works on ISC side, but there's no harm in following your gut for once. Among other things, you should see that it follows a bell curve like pattern. This distribution is kind of like a bell curve. That is something you want to make sure. And the brightness, this R is basically just the brightness or the magnitude of that. It should be more than 20, and it should not fluctuate more than 1. So let's say if this is 20.6 for this particular asteroid, in the next image, when you head over to the next image, it should not be something like 22, 23. It should be within plus minus 1K range, right? Let's go to the second one. So this is 20.4, that was 20.6. So here is the object designation. So the naming pattern that you want to follow here is 3 letters followed by three alphabets followed by 4 letters. So in this case, I'll put in, let's say, joy 4 times 0. So joy 000 is the name of this asteroid. And then you accept it. And then you head over to the next image. You click this again. And then again, write the same name, joy 4 times 0, accept. Then the next image. Joy 4 times 0, accept. And then in the final image, you have to do the same. Right. Now you'll head over to file. Okay, so let's say you're done with all the, this is the only asteroid you see moving in this whole image in all the 9 tiles. Then you'll have to conclude your survey and you'll have to head over to file. Then go over to view MPC report file, and you'll see the report file will be automatically generated. You don't have any use of this file as such, but you'll have to copy the text like this and then head over to the IASC website. Just a second. So you'll have to select the data set for which the data set which you surveyed. So let's say if it's PS2 new practice, then you'll have to add the exact names like this. So in this case, it's just my name. So we'll write J. Agrawal. We'll add citizen scientist. If there's someone else as well who was there, but in my case, there wasn't anyone, but let's just say if there's someone, you'll again write as to Charan and then just add scientist. And then the MPC report file will be pasted exactly like this. Make sure there's no space at the end. It should be all very standard, no spaces at all. And just hit submit report. All right. Now let's, okay, by the way, any questions so far?
How many data files do we get to observe?
Sorry?
How many data files are we getting?
All right. So firstly, you'll be given this practice file. You won't be shared the real files until and unless you complete this practice file. And the findings in the practice file are accurate because so the way they make this practice file is that there's this gap between getting a preliminary result and getting a provisional result. So when your asteroid is a provisional result, it will be added to the MPC orbital database, right? So after that, it will show up on Astrometrica. But in case of preliminary, this gap between preliminary and provisional is when the asteroid is there, but it hasn't really been confirmed by MPC. So it doesn't have any official designation. So the way they design it is that they take such preliminary discoveries and put in these images which have not been so far with the MPC. But Astrometrica guys know for sure that this particular asteroid in this image follows the pattern of an asteroid. So they'll just see if you put in the correct MPC report file with the exact system, naming system and all things, just to see, so just to make sure that you don't mess up the actual files, because they don't have such a lot of manpower to manually check all the images. So they have a computer algorithm that'll just go through everything. And the things that they see are MPC actual discoveries that they think, they'll confirm them manually. And then they'll, at the end of the campaign, they release this thing known as a preliminary report. So it'll include all the preliminary discoveries. There are literally hundreds of preliminary discoveries each campaign, but very few are confirmed. And then the provisional ones are confirmed after. It'll take almost anywhere from 1 to 3.54 years. This is the standard time it'll take between preliminary and provisional. If you don't get anything by 4 years, it means that someone else has already detected that asteroid. It has been detected before you by somebody else. So it won't really count as your discovery. So you won't be informed on that. Right. So after you have completed this, you'll get, let's say, about 20 to 25 image sets.
Sorry, I didn't get you the last part.
Yeah, I said that you'll get around, after you've completed the practice set and it has been approved, you'll get somewhere around 20 to 25 actual image sets.
Actual image sets.
Yes, 20 to 25 actual image sets like this. There'll be 25 rows and each will contain 4 images.
Okay, and
Taking
that will also be for analysis, for measuring, right?
That will be for actual measuring. This is just to test the waters, whether you actually know what you're doing, right?
Okay, so if I'm getting it correctly, this is just a preliminary round, and after that, we will be qualifying to
Yeah,
get
it's
the
the
count.
qualifying round. If you do it right, then you'll get the rest of the images. Otherwise, you won't.
Okay, good.
So that's why this is very important. So I'll demonstrate on Sai Charan's file. Let me see if it's downloaded. Sorry. Any other questions? Mhm. Oh, damn. The internet's pretty slow because I'm using the internet on 2 different devices for the meeting. So the practice set is taking quite a lot of time to download. So I'll demonstrate on a practice set that I already have downloaded from my asteroid search campaign, just to give you all another example of another taste of how all this works. Okay, yeah, we missed something very important. So if you don't find anything at all in the images, no asteroids, you still have to submit the MPC report with IASC, because it helps them keep a track of whether um, there are any discoveries in this and whether they can kind of like destroy the files, right? So if you don't find anything, you just want to go over here, select anything, just type in any random name. Okay, wait, I have to follow that name pattern. So just follow this pattern, except head over here and remove this part. Wait, it's been a long time since I did this. Just let me review the instructions file for what to put in, because you have to type in something here, something like no moving objects detected. So you'll copy this, you'll head over to the IASC website, you'll paste this here. If this is in case if you don't see any moving object, so just select this and write no um, no moving objects. Yep, this is how it should look like. If in case you don't see any asteroid in the image file, make sure it's like this. Yeah, and then you can hit on submit report, and they'll keep a track of that you didn't find anything. By the way, they send these files to 2 3 4 teams at one time, so that they can kind of like compare the results of each team. That's why it's citizen science, so that they can compare the results that they get from various teams and get a good sense of whether they can be classified as a preliminary result or not. So that's how they do the manual confirmation. Okay. I'll give you another taste of how all this works, and then we'll just dive into a Q&A session. And meanwhile, what I suggest you all is that actually download Astrometrica right now and load your practice file and try to do it right now, so that if you have any questions or queries here, you can ask them right away. For those who have already downloaded Astrometrica, you guys should at least follow along so that it's easier for you to do it again. So we'll close this off. Yes. So once you're done in this, once you're done with the one image analysis, you really don't want to close Astrometrica and open it again, because it'll again load the MPC orbital database and it'll take a lot of time. So just analyzing 2-3 image data sets can take you anywhere between 20 to 25 minutes if you do it this way. But you can significantly reduce that time by following the method that I'm doing. So just head over to File and click on Reset Files, and it'll show you this text box. Do you really want to reset MPC orbit, MPC report, photo report, and astrometrica.log? You'll hit click yes, and then this view MPC report file, it'll be blank so that you can load images again and start a fresh analysis. Yeah. So I've loaded a practice set here, and we will perform astrometric data reduction. Any questions? Anything
Yeah, you press the green icon, right?
You have to press the green icon. That's the astrometric data reduction. And then you have to just click OK. Don't click write anything in the text box that it provides you. Just click OK, and it'll take care of the rest. And then click known object overlay, and it'll look for the known objects in this image file.
Which one is known object overlay? Could you please point it?
It is okay. It has disappeared because I clicked it. Just a second. After this is done, I'll show you. Actually, if you hover over these, you'll be able to read them. So this is the known object overlay just beside invert image. This is the known object overlay. Sorry, this is the known object overlay.
Got it.
If you hover over it, you will be able to see. Then blink image. So this is the blink image option. This thing right here. Blink image. So it'll just animate it, and you can set the frequency from here. All right, let's zoom in. All right, you all can start scanning and unmute yourself, and tell me which quadrant of this square tile do you see an asteroid in? And if someone sees no asteroid, just unmute yourself and say no asteroid. I'll wait for you all to do, because it'll be better for you all to have some hands-on experience before actually trying on your practice set. Hello. Guys, can we make this interactive, please? Just unmute and say no, nah, no, you cannot see any asteroid, and I'll move over to
The dots are disappearing, but I cannot see any dot moving in any of the
Right. So
quadrants.
if they're disappearing, they're not really asteroids. You have to have a continuous streak. They can be either in only 3 images or 4 images, but 2 images, it's not an asteroid, right?
In the fourth quadrant, there is something, but I don't think it's an asteroid.
Which quadrant?
In the fourth quadrant, in the extreme right, there comes in the middle extreme right.
Yeah.
No, not that one. The one above that, in the extreme right. There's a black spot, and then it is disappearing.
Yeah,
Above
so
that.
that's not an asteroid, because it's disappearing. It's not really following a streak, and it should be a little bit longer. The streak, not the asteroid. The streak should be a little bit longer. The 4 asteroids, they should be a little bit longer when they're in interplay here. So let's move over to the next tile. Okay, so this is just some data errors that have been caused because of the satellite. So it's not really because of you, so don't worry. Yeah, here, can anyone see anything? Remember, the practice sets can also have no asteroids. They can just give the image to confuse you. All right, guys, can you see anything moving here?
There's a small movement of a very small object in the middle.
This one, right?
We have to check the SR, right?
Wait a second, this one, right?
Yeah.
Yeah, that's not an asteroid. The streak is
Can you
extremely.
click on it and show the SNR?
Yep. So the SNR is 29.3, but come on, you can see yourself that it's not an asteroid because it's following a very small streak, and these images are separated at a very long interval. So
Yeah, I get it.
this is not an asteroid. It can be because of some errors with the telescope itself. So this is not an asteroid. Yeah. Okay. Let's move over to the final tile on the top. Okay. Can anyone see anything moving here?
Yeah, there's a very big movement in top half.
Sorry,
There is a movement in top half, but
top half. Where?
yeah, thing on left and then it is moving towards right, towards middle and right. I don't know if that's an asteroid because it's not a dot. Maybe
Which
it could
one?
be
Which thing? Just point my cursor.
a little bit above, just a
Yeah.
little bit. Yeah, small streak. Yeah, that one. And then it moves towards the right.
All right. That's definitely not anything. It's just some artifacts
Yeah,
caused because of noise. That's definitely not anything. See, if you track kind of like the past of how all this has developed, detected asteroids, they'll be the largest because previously you didn't have more calibrated telescopes, so you could just see larger things. So the asteroids that have been detected, let's say 20, 30 years ago, those will be larger. Those 20 years, 10 years from before today will be slightly larger than we detect today, but slightly smaller than were detected in that time because that was the bandwidth of the technology that we had, right? So we
yeah.
were limited and we were able to detect only up till that point. So let's move on to the next tile. Does anyone see anything moving here?
I don't know what that is in the first quadrant. Definitely not something like an asteroid, but it's a trail.
Where in the first quadrant are you saying?
You see a trail like a long black line in first quadrant, top.
This thing?
Exactly.
No. That's nothing. That's artifacts and noise because of calibration errors with the telescope, or let's say solar flares or something like that. So that's not at all an asteroid. Okay, next quadrant. Yep, here. Does anyone see anything moving here? No, right?
No.
Again, there's a line of artifact here, so we'll just ignore that and move over to the next tile. Right here. Is anyone following along with their practice set? Okay, again, there's nothing here either.
Again, no.
Sorry.
Again, no movement in this picture.
All right. In this one,
There is an asteroid.
perfect, awesome. Yeah, that is an asteroid. That indeed is an asteroid. Um, in fact, like sometimes there will the SNR won't match, but your gut will say that that's an asteroid, that's something moving. So there is no harm in say in putting in that one thing as an asteroid. That is strictly for when you are actually analyzing, not doing the practice set, because practice set is kind of like the ideal environment where they'll try to keep everything standard. Okay. So let's name this, let's say Joy 001. Name it with a like in some kind of fashion so that when you create that Excel sheet on your end, a database of image set and the name of the asteroid that you've put it up, uh, name it something standard and something incrementing so that it's easier for you to keep track. Then we'll click accept, move on to the next, click here. So you see the magnitude in the previous image was also 20.4, and in this image it is also 20.4. Then Joy 00.
20.4 is the radius of that asteroid, I
No, no, no,
think.
no, no. 20.4 is the magnitude. Magnitude
Mm.
as in brightness of the asteroid.
Okay, okay. Yeah,
Of
got
course,
it.
it's not the radius. Yeah. Wait a second. Oh, I did something. Did it in the wrong style. So we'll just reset it and then start again. The first time the asteroid appears is okay. The first time the asteroid appears is here. So we'll click here. So if you see, there's just a 0.1 decrement here in the magnitude. That's just because of, again, the artifact or the noise of
Yeah, we get it.
thing. So that's fine. All right. They'll adjust for that. And then the final image is right here. See, yeah, now this is a good example. So it was earlier 20.4 and here it is 19.8. So as I said, plus minus one increment is okay, but larger than that, it can be, it has the potential to be rejected by IISc, even though it might be a real asteroid, it can be rejected because they won't really see it as the same object moving to different place because the magnitude has decreased. But in this case, it's plus minus 1K arrangement, so there won't be really a problem. Let's say if it was 18, then that would have most surely been rejected by IISc, even though it would have been an actually an asteroid, but their algorithm is such that it is mostly automatic and it's kind of like the computer doesn't have an instinct or it's cut, so they'll reject it. Okay, now that we're done with referencing all the images, you'll have to start over and look for the others. So this is already done, right? Now we'll head over to the next tile and look for any other moving objects that we can see here. All right, anyone, any moving objects? No. last time. Does anyone see anything moving here?
No.
Mm-hmm. All right, yeah. No, right? But just in case, if you detect two new asteroids in the same image set, you will have to name it again, but make sure that you put it as so the first asteroid in this image, I put it as Joy 0001, right? Now the next one, name it as Joy 0002. And for all the image sets that you analyze in the future, in this particular campaign, never again use the same name, let's say Joy 0001. Never again use it in the next image set. You can use it in another competition, as let's sorry another campaign, but not in the same campaign, because when they release the preliminary report, there'll be a mess up if you name it the same thing. All right, so this is done. We'll head over to wait, what just happened? Why is the NPC report file not here? Okay, let me load this again. Probably because I reset it while this was already there. So that's why there was an
It's
error.
okay, you don't need to, I guess. We have all seen how to do it now,
Oh,
right?
yeah, here. Okay, you can see the MPC report file, right? So here it is. Now you'll just copy this MPC file, go to Google Chrome and paste it here. And let's say I have put it here, MEA as joy.agrawal. Just select joy.agrawal and the image set and click submit report. So that's that. All right. That is all from my side. If you guys have any questions here, you can absolutely shoot off. Any questions? Anything that you want to be clarified? All right, Saicharan, over to you.
Yeah, thank you very much, Joy, for the whole presentation at such short notice. So, all right, I think
Thank you, Saicharan, for having me.
it's been great having you. So, I think that's all for today. If you guys have any query regarding anything, just email me to the same address that we've been using for all communications. And we really want to see all of the data sets that you have been assigned thoroughly analyzed and all the MPC reports submitted. So thank you for joining today and happy asteroid hunting.
Bye, guys. All the best.